because some of these things are basic algebraic concepts. So how to solve an equation. If you talk about linear equations with one variable, then that's kind of what we're starting out with here in the first section. Got absolute value equations, and we'll also look at equations that have rational expressions in them. So the first section is just going to be about introducing equation solving, and then we'll kind of build up on that as we go ahead in this course. Okay, no problem, Shayna. Yeah, thank you for letting me know. I know that can happen sometimes. So each section of chapter 1 is going to feel like a review section, because these would be concepts that you would have seen maybe in like an intermediate or a basic algebra course. So this is actually a good place to start, because it gives you a little bit of overview. It helps you refresh some of the concepts that maybe you've forgotten over time if you haven't used it in a while. So you can see here we start out by talking about an equation. An equation is basically where you have any two um, algebraic expressions that could be equal to each other. So you can kind of see an example right here for the equation. Now, when we're talking about a linear equation in one variable, in the standard form, it would end up looking like ax plus b equals 0, where x would be your unknown value. And we put a little restriction on that a that you're multiplying the x variable with, because we don't want that a to be 0. Just think about it. If this a value was 0, 0 times x would end up becoming 0, and your variable would completely disappear. So obviously we don't want our variable to disappear, and so that's why we put that little restriction. So when we talk about finding a solution for these equations, basically the idea is we're trying to find the value of x. So they're saying, okay, let's say we use x equals 3 in this case. When you plug that into your formula or your equation in this case, you will end up getting 6 minus 6, which ends up giving 0 equals 0. And that's a true statement. It's true because the left-hand side and the right-hand side are the same number. So when this happens, we can say 3 is a solution to our equation. So you can use the term solution. Sometimes they call it a root. But basically, we are saying that the number 3 satisfies our equation. Now, let's say instead of x equals 3, we ended up replacing our x with the number 2. So in this case, you will see when we plug in 2, you get 4 minus 6, and 4 minus 6 ends up giving us negative 2 equals 0. And of course, this is a false statement because my left-hand side does not match my right-hand side. So of course, in this case, we would say 2 is not a solution, or 2 does not satisfy our equation. So anytime, we're asking to find the solution to an equation, you're looking for numbers that will satisfy the equation. So again, this will be something you're familiar with. Anytime we talk about solving an equation, remember how we can move our terms to either side of the equation. So the idea is if you add or subtract two numbers, or add or subtract a number to both sides of your equation, it will still help you maintain the balance of the equation. Or basically, if you're performing the same operation on both sides of the equation, you're not changing its value. So if you're adding or subtracting, we call that the addition or the subtraction property for our equations. You can also multiply and divide by the same number on both sides of your equation. The only exception here is, obviously when you're multiplying or dividing, you don't want that number to be 0. Because if you multiply both sides by 0, you'll just end up getting 0 equals 0, and you're not really solving the equation anymore. Everything just ended up becoming 0. Now be careful about dividing by 0, because remember, division by 0 is undefined. If you end up dividing both sides by 0, then again, you're not going to be able to solve your equation at that point. So that's why we put those little restrictions on multiplication and division. But all of these properties basically help you solve an equation. So we've got a few examples over here. Now you should have seen these examples in the video lecture. So I'm actually going to pull up some examples from our homework here, and let's work through that so we can make sure you guys are comfortable with equation solving here. The first couple examples are going to be about terminology, but let's see if we can pick, we'll come back to that one. How about this guy over here? So remember, our goal here is basically to find the X value. So I'll give you guys a couple minutes. Let me see what kind of answer you come up with for this example over here. If you've got a scratch paper with you or a notebook, you know, just use that. Okay, and what I would like you to do is don't send the answer till I ask you to. If you want to type it in your chat window, you can, but just don't hit enter. When I ask you to, do it then, because you know I want to see what everybody comes up with at the same time. So just solve your answer. Type it in the answer in the chat box, but just don't send it yet. Okay, so do you need more time or you think you have the answer? You have it? Okay, go ahead and send it, folks. All right, looks like all of you are coming up with 7, Abdulaziz, James, Robert, Trey, Alicia, Shayna, Ryan, okay. All right, so let's take a quick look at this example over here. So you've got 6 plus 2x equals 4 times, in parentheses, the quantity, x minus 2. So can one of you tell me where did you start with this problem, on the left-hand side or right-hand side?
I started on the right and just distributed first.
Distributed the 4 inside the parentheses? Yeah, very nice. That's exactly where we want to start. So you want to take that number 4, move it inside the parentheses. So you will end up getting, of course, left-hand side will stay as it is. And then 4 times x will give us 4x. Minus 4 times 2 is 8. And then, you know, bring in your x on the same side. So you can think of this as the subtraction property. So this will give us, let's see, I'm going to move my 2x just to kind of keep my numbers positive here. That would be minus 2x. And let's see, we can move the 8 to the left-hand side. So 8 plus 6 will end up giving us 14. And then, of course, 4x minus 2x gives you 2x. Divide both sides by 2, and you should have x equals 7. All righty, nice job, guys. So we'll go ahead and type that in. Okay, Oliver, you are talking about using the commutative property on the left. Yeah, because you're basically just combining the like terms, right? To make sure that all your like terms come together, and then you're just getting your variable by itself. Now, I did want to show you something very quickly, and if you guys have used MyMathLab before, then you would be familiar. But you can see how when you click on that little answer box, all of these different menu options pop up on the bottom. Okay, so you should see right here on the bottom of the screen, all of these different menu options pop up. So if you want to type a fraction in there, you know, raise your number to an exponent and that kind of thing. So all of those different menu options will pop up when you put trying to put your answer in. All right, see, so now that we have our answer done, let's go ahead and check this answer. And there you go. Okay. Alrighty, so let me go ahead and clear this out. Now for this example, does anybody have an idea what you would do if you wanted to try and solve this? Where would you start?
Do you want us to keep it in fraction form or reduce it to a decimal?
Oh, I would keep it fraction because some of these would not be a clean decimal because that 1/3 will actually come out to be 0.333 repeating. So yeah, just let them stay in fraction form. So if you actually look at your handout for 1.1, and I'll come back to these identity, conditional, and inconsistent equations here in a minute. Okay, Abdul Aziz, you're talking about collecting your like terms. Okay, yes, that would be definitely a good start. But you know, I am one of those people who actually prefers to get rid of my fractions if I can, because if I don't have to worry about, you know, working with fractions anymore, then the process goes a lot faster for me. So what I normally do is I try to find out what the least common denominator would be for my equation, you know, looking at all the denominators. And once we find out what the least common denominator is, then you multiply your entire equation by that least common denominator by the LCD, and it actually, you know, will get rid of any fractions that you have. And you've got a bunch of different examples over here. So again, if you look at the video lecture for this section, you will see I have worked all of these problems out. So let's go back to our example over here. And let's find out our least common denominator. So your denominators right now are 4, 2, 8, and 3. So what do you think would be the least common denominator by using all 4 of those numbers?
Yeah, 24.
24, yeah, very nice. And so just to make sure that everybody's comfortable with how we came up with that 24, let's take each one of these denominators and break them down into factors that have prime numbers. So like for number 4, we can break it down into 2 times 2. 2, of course, if you want to write it down, you can write it as 2 times 1. 8, again, you can break it into 4 times 2, but I want to do this with prime numbers. So it's actually going to break down into 2 times 2 times 2, right? So just breaking it up into its prime factorization, and 3 again will just be 3 times 1. So if you look at all of these numbers that we have on the right hand side, you will notice we have a repetition of 2 for those first 3 numbers, 4, 2, and 8. So I'm going to go ahead and write that down once. All right. Then we have this number 2, which again is repeating. So we can go ahead and write that down once. And then we're going to take all the leftover numbers and write all of them down too. And if you want, you can include the 1 in there also. So when you go ahead and multiply all of these numbers, you will notice we again end up getting that same answer you guys gave me of 24. So that's another way of thinking how you can calculate your least common denominator. So just keep in mind, if any number is repeating, you only need to write that down once. So I have, you can see how I did this. A bunch of those 2's were repeating between 4, 2, and 8. I go ahead and write that down once. Then between 4 and 8, I had another pair of 2's that I could use. I go ahead and put that down. Then I had the single remaining 2 over here and the single 3 that I also bring in, and multiply everything to get your least common denominator. Now the next step is going to be where you are going to take this LCD and multiply your entire equation by that number. So that means each fraction or each term is going to get multiplied by this 24. So you would do 24 times 1/4 x plus 24 times 1/2. And then on the other side of our equation, we would do 24 times 1/8 x minus 24 times 1/3. So each term. So Oliver, this would be problem number, oh, what problem number was this? This is the 7th problem in section 1.1. Your numbers might look a little bit different than mine, but if you just look at the 7th problem from your MyMathLab homework in 1.1 section, you will see a problem similar to this one. So let's go ahead and get rid of our denominators now, because remember, that's the process we are doing. We're trying to get rid of our denominators here. So you will notice 4 will go into 24 6 times. 2 will go into 24, of course, 12 times. 8 will go into 24 3 times. And then, of course, 3 will go into 24 8 times. So after you put this together, let's see, we will end up getting, since we cancel those out, you are now left with 6 times 1x plus, let's see, 12 times 1. And then on the other side, you will have 3 times 1x minus, what will that be, 8 times 1? So go ahead, simplify this, and let me see what kind of x value you are coming up for this equation. Now, and you can see it really helps you simplify the problem down. Okay, again, Abdulaziz, wait till I ask you to send the answer, okay? So I want you guys to work on the problem, and then when I ask you, send me the answer at that point. But, you know, if you get rid of those denominators, then it really just makes it a straightforward problem. Then you don't have to worry about what do I need to do with my denominators. Now, I know some of you may have seen this solved in a different way, maybe in a different class. So if you are comfortable with that method, you don't have to follow my method. You can do the one you have seen previously in your class and just go ahead and use that method. I'm definitely okay with that. And the other thing I do want to point out, with each problem here, you will see underneath the little answer box, they will have instructions on how they want you to type your answer in. So you can see they are specifically asking us for an integer or a simplified fraction, so no decimal answers in this case. So just keep that in mind as you are coming up with your final answer. Okay, so do you have your answer? Okay, so don't send it just yet, just type it in your chat window. And when I ask you to, send it. So just go ahead and type your answers, get it ready. All right, go ahead and send it in. Okay, so you've got minus 20 over 3, minus 20 over 3. Okay, negative 20 over 3, Trey, Nathan, James, Abdulaziz. So what was that 4/3, Abdulaziz, at the beginning that you had? Was that a miscalculation or something? Yeah, okay. Alicia, you think you lost your negative somewhere? Okay, no problem, we can help you find it. But looks like in general, most of you are coming up with negative 20 over 3, and Ryan, you're converting it to a mixed number. Since they're specifically talking about simplified fraction, let's leave it at negative 20 over 3, okay? So basically, once you try and simplify this, you will of course see 6 times 1x will just become 6x, 12 times 1 is 12. On the other side, 3 times 1x will be 3x, and then minus 8 times 1, of course, is 8. So let's say we move our negative 3x, or move our 3x to the left-hand side, and we'll move our 12 to to the right hand side. So Alicia, this is actually where you will end up with that negative sign. Even if you move the 6x to the right and 8 to the left, you should still have a negative left behind from there. So let's see, if we clean this up, you should end up with 3x on the left-hand side and negative 20 on the right-hand side. And there you go. That's where your negative 20 over 3 is coming from. All right, nice job, guys. So again, we'll go ahead and type this in. So negative 20 over 3, and let's do a quick check on that. There you go. Okay, very nice. I'm gonna go ahead and clear this out. And so you will see there are a couple different examples here that are going to be, does it come over? Yeah, so you've got a couple different examples here, and I have shown you how to do these examples in your handout right over here. So I would again say follow the instructions from the video that you watched to help you simplify this. But before we move on, I did want to talk about these identity, conditional, and inconsistent equations here. So this is basically just defining, you know, what kind of solution sets you're going to have, and based on that, we classify each of these equations. So when we're talking about an identity, we are saying that is an equation which can be satisfied by every real number for which both sides are defined. So if you look at this, these examples over here, when you've got 2x minus x, if you simplify that side, you will end up getting x equals x. So whatever number you have on the left-hand side is going to be the same number on the right-hand side. So you will, of course, end up getting a true statement over here. For this one here, then we can say that your solution set is going to be the set of all real numbers. If you look at the second example, you've got 3x minus 1, 3x minus 1 on both sides. So you know whatever value you put in for x, your left-hand side answer is going to match the right-hand side answer again. So again, you're going to end up getting a true statement, which means again, you're looking at the set of all real numbers. So basically anything from negative infinity to positive infinity will satisfy those first two examples you are seeing. Now on this third one, this is actually an interesting example over here because we have x divided by x. So even if you just think of x divided by x, if we divide those two values, you will end up getting 1. And so of course you end up getting 1 equals 1. But if you actually plug in numbers for x, so you can have 3 over 3, you know, negative 10 over negative 10, you are still going to end up getting 1 equals 1, which is going to be a true statement. But the one exception in this example is going to be because you have that x in the denominator, because of that x in the denominator, you will actually only be able to use numbers from the real number set, which are not a 0. So that's why they are saying your solution set is going to be the set of all the non-zero numbers. Or basically we are saying, you know, the set builder notation is what we call this here. You're basically saying x can be any number except 0, because the moment you put 0 in that denominator, you are going to end up getting 0 over 0, and 0 over 0 is undefined. So that's why you have to put a restriction on the value of x you are coming up with. And you know, that's actually going to be true for all of these equations over here, where you can see we have our variable x or t or w in the denominator. So there's always going to be some number which will end up making your denominator 0, and you will have to exclude those from your answer set. So that these are going to be, all of them are going to be examples of what an identity equation is going to end up looking like. Now, when we're talking about a conditional equation, we are saying basically there's at least one number which will satisfy this equation. But unlike the identity where we say, you know, every real number or all the real numbers, that's not going to be the case here. So look at this example over here. You are given 2x minus 6 equals 8. So we are saying the only condition under which this equation will be satisfied is going to be when x equals 7. So that makes it a conditional equation. That first example we looked at, right over here, 2x minus 6 equals 0. This would again be an example of a conditional equation because it was only satisfied when x was equal to 3. So these would be our conditional equations. And then you also have inconsistent equations, and this happens when you have no solution to your equation over here. So let's look at these examples over here. You've got 5x equals 5x minus 2. So of course my left-hand side does not match my right-hand side. This is not going to be an identity. When we try to solve this by subtracting that 5x on both sides, you will see that 5x and 5x will end up canceling out and leaving us behind with 0 equals negative 2. And of course, this is a false statement. So you can see our x disappeared. We're getting a false statement, so our conclusion would be, yeah, there is no solution to this equation. If you look at the second example, we are multiplying 0 times x. So 0 times x will end up becoming 0. Your x will disappear and you will be left behind with 1 equals 2, which is again a false statement. So again, our conclusion would be no solution. In the third example, if we try to bring our x's on the same side, again, you will notice those x's cancel out, leaving you with 3 equals 5. Oh, are the rest of you having the same problem? Robert just messaged me saying his screen went dark and he can't see anything.
I had the
Can see
same
you fine.
problem earlier. Yeah, I'll go talk to him because I got through it.
Okay. Robert, are you still having trouble? Technology, there are only so many things we can do with it, isn't it? Darby, you disappeared on me.
He should be back on soon.
Okay. All right, guys. So as you can see in all the 3 different examples that you saw here for the inconsistent, essentially your x variable is disappearing and you're ending up with a false statement. So you can see in all of those situations, we are saying it's an inconsistent equation. So if you look at examples here in your homework, okay, this looks to be the first one. What kind of equation do you think we have over here? We are given 6x minus 4, 6 quantity x minus 4 equals 6x plus 24. So do you think this is going to be an inconsistent, identity, or a conditional equation?
Yeah, like Abdul Haziz said, because if you distribute on the left side, then it'll end up as 6x minus 6x minus 24, which would not work.
So what do you classify this as?
Inconsistent.
Inconsistent, yeah, very nice. And that's exactly right, what Nathan said over here. So you can see after you distribute that 6 inside the parentheses, you have 6x minus 24 equals 6x plus 24. And again, if we try to combine and get those 6x on the same side, they will actually end up canceling each other out, leaving you behind with minus 24 equals positive 24. Okay, Oliver, you had no trouble. Abdulaziz, you're giving me the answer. Okay, very nice, inconsistent. So in this case, you can see since we are getting a false statement, then you are obviously going with option D over here. So let's go ahead and check that first because it will have you do it in two parts for this problem. So we'll go ahead and check our first part, and then it's actually going to pop up with the question for conditional identity or inconsistent. So of course, this guy is now going to be an inconsistent equation, and we'll check our answer one more time. And there you go. Okay. Right, let's see. Okay, so same thing, what kind of equation do you think this example is going to be? 8x divided by x equals 8. Looks like Trey, is Robert still having trouble? Because I don't think he's come back to the class just yet. Okay. He should be able to catch up with us though. Go ahead. Would you say that one more time, please, the answer?
All real numbers.
All real numbers, okay. Anything that wouldn't work
Not
in this
zero.
case? Not zero, yeah, exactly. Because again, you will see our x is in the denominator, and because of that, we will have a restriction. So this is very similar to the example we just saw over here in our handout with x over x equals 1. So yes, this will be an identity with the exception of not being able to use 0. So you don't want your denominator to be equal to 0. So here you would basically be going with option B because we do have to put that restriction on our x value. So you would say it's all real numbers except 0, or like this in our handout, it can be all non-zero real numbers. So again, we'll go ahead and check our answer over here. And then for the second part, they will ask you to identify the type of equation, and this will be the identity. Alrighty. Now this example over here is going to be very similar. There's Robert. It's going to be very similar to what you have in the handout right over here, this number 7. So look at number 7 from your video, and I would say follow those same steps to try and solve this. And you should be able to come up with the answer. Again, this is similar to what you have in the handout. So all of these examples are available to you in the handout. So, you know, follow those instructions. Now, I do want to talk about these absolute value equations. And, you know, absolute value is actually something that's going to keep showing up in different sections, in different chapters in this class. So I want to make sure you guys are comfortable solving absolute value equations. And then later on, we'll be looking at absolute value inequalities as well. So can somebody tell me, what do you understand by absolute value? So if you were given like absolute value of, I don't know, -7, what would you get?
Negative and positive 7.
Okay, so let me ask you that one more time, because I'm asking you if I gave you absolute value of -7, what would your answer be?
7.
Yeah, just +7, right? You would not have negative and positive. In that same sense, if I gave you absolute value of, I don't know, 2179, what would that be?
Still 2179.
Yeah, it would still stay positive, right? So you know, with absolute value, a negative will become positive and a positive will stay positive. So does anybody know why that happens with absolute values? Why does a negative become positive and why does a positive stay positive?
It's all relative to the distance from 0.
Yeah, very nice, Oliver. Exactly. It is about the distance being from 0. All righty, very cool. So the idea here is, let's do a number line. 0 will be in the middle. So if you look at this example over here on your handout, we are talking about if x equals positive 3, you've got absolute value of 3, which ends up giving you the number 3. So you're basically talking about, when you're saying absolute value, you are saying how far is that number away from 0, and of course that's going to be a distance of 3 units. Now, when your x value is negative 3, of course, we're talking about the number here on the left-hand side. So if we again think in terms of just the distance, that is still a distance of 3 units. You're just going in the other direction. So you will notice with the absolute value of negative 3, you actually end up multiplying negative times negative, making it into a positive 3. So this is actually how we define an absolute value function. This is what your original definition for an absolute value is. The positive will stay positive, but the negative is essentially being multiplied with another negative sign to convert it into a positive. So anytime you come across absolute values, just remember we are talking about the distance of that number from 0. And if it helps, you can always think of this as, when we talk about distances, let's say you were trying to give somebody direction from, Greeley or something to Denver, you would just say, basically go, I don't know how many ever miles, that must be 50 miles or whatever, south, on I-25 to get to Denver. We would never say, you're going negative 50 miles from Greeley to Denver. So we never really use negative when we're talking about distances. So that's the same concept you're using here with absolute value. Now, when it comes to solving absolute value equations, if you have an equation in this form where it's absolute value on one side and you have a positive number on the other side, for these type of equations, you actually have to break them down into positive or negative, because again, the idea is, are they going to be on the positive side of 0? Are they going to be on the negative side of 0? So that's why we always break them up into 2 parts, x equals negative k or x equals positive k. Now, if you have an equation in the form where you get absolute value of whatever number might be equal to 0, so you don't have a positive number on the right-hand side, you just have a 0. In this case, you don't really do positive 0 and negative 0, because honestly, 0 doesn't take a sign. So you just end up doing one equation as x equals 0, and then you solve that. Now, think about this. This one is saying if you have an equation where you have absolute value equal to a negative number, so something like this, absolute value of x equals negative 7. So think about this just a little bit. Again, let's put this on a number line. So we can have 7 on the positive side, 7 on the negative side. But if we're talking about the distance from 0, then we know both of these distances are going to be positive 7. So remember what I said, distance cannot be negative. So when they give you an equation like this, where you have absolute value of x equals negative 7, you will actually have no solution, because my distance will always come out to be positive. My distance cannot be a negative number. So that's why for these last type of equations, you will see we are saying the solution set is an empty set because you have no solution. So 3 different scenarios you kind of have to think about when you are working with these absolute value equations. So let's try and do a couple examples over here. Okay, why not? Let's start with this guy. So what do you think about this one? What kind of solution would we have for that x value?
There would be no solution, right? Because the There's a negative k on the right side.
Yeah, exactly, because you just have absolute value on one side, and it really doesn't matter what's on the inside of the absolute value. It's just absolute value on one side and negative number on the other side. So this is definitely, like you said, Abdulaziz also and Oliver, that this would not be, you would not have a solution for this. So this is definitely an empty set. And in this case, they're just asking you to click the one that says no solution.
What if the solution has a complicated answer resembling almost a fractal almost? Would that be an incomplete set or an imaginary set, something like that?
So normally we would be talking about imaginary, but again, with absolute value, you don't really have the chance to get an imaginary solution. But if this was like, with square roots, yes, we can definitely come up with imaginary solutions. But for absolute value, because again, we were talking in terms of those distances. So you're just trying to figure out, can you have a distance of -20? And of course, the answer is no. So in this case, you would actually, it's not even an incomplete set. It's just you don't have a set. It's an empty set. So yeah, just no solution. Sometimes they use that little empty set symbol. Sometimes they will just have you do, just this bullet point with no solution. All right, let's go ahead and check this answer quickly. Okay, and then I did want to solve one of these. So let's go ahead and take a look at this example over here. Now, I do want to point out, when you are solving an absolute value equation, let me see. There we go. You always have to isolate your absolute value. So you always want to make sure you get that absolute value by itself on one side and move everything else to the other side before you can actually simplify your absolute value equation. So in this case, what we need to do is basically go ahead and get this absolute value of y plus 3 by itself, which means we will need to move our -24 and that +4 over to the other side. So let's start by doing that first. So we will start by moving that 24 to the right-hand side. So let's add 24 on both sides. We are left behind with 4. Absolute value of y plus 3 equals 24. And since you are multiplying the 4 with the absolute value, to get rid of that 4, we will go ahead and divide both sides. And of course, this ends up giving us absolute value of y plus 3 equals 24 divided by 4, which would of course be 6. Now, once you get it down to this stage, then, and of course you can see we have a positive number on the right-hand side. So that means you're looking at this first case scenario where when you have a positive number, we break this up into a positive and a negative equation. So this is what we will do here. We will take our absolute value of y plus 3 equals 6 and rewrite this as y plus 3 equals 6 or y plus 3 equals -6. So you will see the value that was inside the absolute value symbol stays the same. The right-hand side will now become positive or -6. And you should come up with 2 different answers. So again, don't send me your answers just yet. Go ahead and type it in your chat window. And when I ask you, then you can send it to me. Okay, if you're ready, go ahead and send your answers in. Okay, so let's see, we've got +3, -9, Abdulaziz, James, Nathan, Shayna, Alicia, okay, Floor, Okay. So each of those equations should be giving us an answer, Robert. Okay, Ryan, very nice. So we will start by getting y by itself, which means we move that 3 to the other side. Trey, alrighty, very nice. So you've got y equals 3 on that first part. And then we're still subtracting 3, but since you had -6 on the other side, that would of course end up becoming -9, right? Okay, Oliver just saw your answer. Okay, very nice. So you're getting +3 and -9. So we will of course be plugging this into option A. So you can do 3 comma -9, or you can do -9 comma 3. And then of course we want to check our answer. And there you go. Alrighty. So just remember to always isolate your absolute value symbol before you start solving these equations. This example is not in your handout, but hopefully it should not be too difficult to try and solve. So anybody have an idea of where you would start if you wanted to solve this example? And you know what, I'm actually going to open up my notebook so we can solve this example in a bigger space. So how would you begin this problem? Where would you start?
So I would start by removing or working out the x minus 2 squared, so x minus 2 times x minus 2.
Yeah, very nice, James. Exactly. So you actually want to do FOIL on the left-hand side because, you know, factorize the right side. Yeah, we can do that. Also, in this particular example, because x minus 4 can actually be factored on the right-hand side, but the only problem with that is going to happen is if you cancel out any of these terms, there's a potential we can end up losing one of our answers. So instead of factoring the right-hand side, we will actually FOIL the left-hand side. So let's start with, let me go ahead and write down this example here. So we've got x minus 2 Yeah, exactly. That's right, Oliver. So once we simplify our equation over here, then we will be able to combine the like terms, bring everything on one side, and try and simplify it. So you've got x minus 2 quantity squared equals x squared minus 4. So the first thing we're going to do is go ahead and do FOIL on the left-hand side. So that will end up giving us, as James said, x minus 2 multiplied with x minus 2. So remember, with FOIL is where you take the first terms, multiply together, you take the outer terms and multiply them, inner terms, and then the last terms from each parentheses. So that ends up giving us x times x, which is x squared. Then x times x from the first parentheses minus 2 from the second parentheses. So x times -2 is -2x. -2 from the first parentheses, x from the second parentheses, so -2x again. And then -2 and -2 from both of them. So that would be negative times negative is positive. 2 times 2 is 4. Then combine your middle terms, and you end up getting x squared minus 4x plus 4. So we'll go ahead and come back to our equation. Bring the right side down as it is, and now you're combining like terms. So you want to get you know, your x squares together, you want to get your constant terms together. So the good thing in this example is, you know, when you try moving that x square, you will of course notice that your x square actually cancels out, which brings us back to a single equation, or you know, a linear equation with just one variable. So this is what we would be left behind with. And again, now our goal is to solve for x. So go ahead, find your x, and when I ask you to, you can send me the answer. So let me see what you guys can come up with. 4x. So just type it in your chat, and when I ask you to, you can send it to me. Oliver, did you have a question? No? Okay. Okay, go ahead and send your answers in. Alrighty, we're getting a bunch of 2s from all of you. Yeah, and that's what I was coming up with myself, because, you know, we would start by subtracting that 4, moving it to the other side, which would end up giving us negative 4x equals negative 8. There we go. Negative 4x equals negative 8. And then when you were to divide by negative 4, your 2 negatives would disappear. Oh, you lost your negative again, Alicia? Alrighty, so those 2 negatives will end up becoming positive, and then of course, 8 divided by 4 ends up giving you that positive 2 answer over here. So let's put it back into our example over here, and let's see what MyMathLab has to say. Alrighty, let's see. So Oliver, in this case, remember, because this is the type of an identity, if you guys can see in the chat, Oliver is asking about a function like 3x over equals 3. So remember, this is an identity where your solution set would be all real numbers except 0, because since you have x on the denominator, it would give you an undefined function if you use x equals 0. Okay. Alrighty, so like I said, this was one of those examples which was not in your handout, but it's not too hard to try and simplify this, especially since your x squared term will end up canceling out. Alrighty, let's see. This example here, again, I would recommend using, you know, if you wanted to get rid of your denominators, you can find the LCD and get rid of your denominators. Or you can try and simplify it first and then find a common denominator. So again, use the examples from your handout to help you solve this example over here. So another absolute value example here, and again, just like you saw in that previous example we did, you want to go ahead and try and isolate that absolute value expression first, move everything to the other side, which in this case would be moving that 6 and 2 to the other side. So I'll give you guys a couple minutes and let me see what kind of answers you come up with for this example over here. Okay, so just make sure you just type your answer in the chat window. When I ask you to send it, you send it at that point. Okay, go ahead and send it, guys. Okay, I've got 5/3, 3/5, 3/5, 5/3, 3/5. Oh wow, so you guys are giving me both combinations of 5/3 and 3/5. Okay, got a couple more 3/5 coming through. All right, let's take a look at why it's one or the other way. Let's see. So as I said, we will first need to, okay, James, you're fixing it to 3/5, okay? So we are first trying to isolate our absolute value symbol. And as I said, we would be moving these two terms over. So that means we would have 6 plus 2 times absolute value of 5x minus 3 equals 6. We would start by subtracting that 6. And looks like that would actually end up giving us 0. And when you divide by 2, you would actually still end up only having 0 on the right hand side. So that's actually that second type of equation we were looking at. So that's this case over here, where if you have absolute value equal to 0, then you just set up your equation as x equals 0. So obviously, for our example, that means we would be just setting this guy up as, Oliver, you're also fixing your answer, okay? So since we now have just absolute value of 5x minus 3 equal to 0, then you are setting this up only as one equation and get x by itself. So you start by adding 3 and then dividing by 5. So it should be positive 3/5. So those of you who were coming up with 5/3, just be careful, when you are simplifying this, because the single constant number moves to the right first, and then you divide by the coefficient of x. Okay, no problem, Oliver. Alrighty, so let's do a quick check on this one, and we have 3/5, and there you go. Alrighty. So just another example with those absolute values. Go ahead.
I just wanted to ask, when I set that problem up, I divided the entire thing by 2 and got to the same answer. Is moving the 6 or dividing by 2, is one better than the other, one more right than the other?
Right, and then you would still be subtracting the 3 and 3, right? Yeah. Yeah, because you're still going to end up getting just that absolute value of 5x minus 3 on one side and 0 on the other. Alrighty, so that was, and I think, James, basically you are actually starting out with using the division property first, since you're dividing everything by 2 first. You're starting with the division property, and then you would be using the subtraction property. Okay. So what do you guys think for this example over here? What would you do? Where would you begin?
Locating a common denominator.
Locating the common denominator. Okay, yeah, so you can definitely find the least common denominator, which in this case, since you have x plus 2 as one of the denominators and x plus 6 as the other one, together, product of those two would actually become your least common denominator. So again, if you wanted to get rid of the fractions, you can go ahead and multiply your entire equation by both of these expressions. And as you can see, on the left-hand side, the x plus 2 would cancel out, and you would be left behind with the x plus 6. So you would be left behind with x plus 6 here, and the x plus 2 would cancel out. On the right-hand side, when we multiply by the LCD, the x plus 6 would cancel out and you would be left behind with x plus 2. So you can definitely use the LCD. But the other thing you can do over here, because you know this equation, if you look at the original equation, it's of the form of a over b equals c over d, right? Because I have only one fraction on the left-hand side and one fraction on the right-hand side. Now, if you had something like, you know, x minus 5 over x plus 2, and then I don't know, maybe plus 15 or something like that equals x plus 3 over x plus 6. So in this case, you would definitely want to use the LCD and move forward from there. But we don't really have an extra term like this. So you only have one fraction on the left, one fraction on the right-hand side. Yeah, Abdul Aziz, that's exactly where I was heading. So you can use cross product also in this particular example. You can use cross product and still come up with the same answer. So if you try and do that, you've got x minus 5 over x plus 2 equals x plus 3 over x plus 6. And if we use this idea of cross product, then you would end up getting, let's see, x minus 5 multiplied with x plus 6, and you would end up getting x plus 3 multiplied with x plus 2, which is the same thing, you know, if you use the LCD that I was showing you right here on our problem. So either way, you're going to get to the same result. And then at this point, remember guys, we are multiplying x minus 5 with x plus 6 or x plus 3 with x plus 2. So just like you saw before, you would need to do FOIL on both sides of your equation, and then you would bring your like terms together on the same side and then solve for x. Now I'll give you a heads up. Again, in this example, your x squared terms will end up canceling out and you will be able to find x. So that will be your final step, is just finding x once you have simplified the left-hand side and the right-hand side. So I will let you work that out as you are going through your homework. And you know, for any reason you get stuck on anything, you're definitely welcome to send me an email or, you know, see me during office hours and we can work through that. But give it a try and let me see, you know, what you come up with. Oops. Okay. Let's close that guy down and we'll clear this out. All right, so this is from your section 1.1. Now let's look at what our section 1.2 will end up looking like. Now you've seen the video lecture for it, so you know this is where we kind of talk about modeling for our equations. So how would you use an application where you are not given an equation and try and, you know, come up with your own equation and then try and solve that problem? Now, if you look at your handout for 1.1, the last example in that handout was actually talking about how we can model real life situations. But in this case, they were actually giving you the equation. You were given the equation, they were giving you some information about the equation and then asking you to find, you know, in what year would the median income for women in the United States be $25,000. So in this example, you know, you are given the equation, but if you look at the examples here from section 1.2, we are not given the equation. So we're actually coming up with our own equations. And in this type of examples, you can either use any known formula if you think it will apply to the application we are looking for, or maybe the problem itself is giving you the setup of what your equation might end up looking like. So one of the more common equations we have is the distance, rate, and time equation. And to remember the order of these variables, just remember the word DIRT, D-I-R-T, because that would be in the same order as what this formula is. And of course, instead of I, you would have the equal to sign. So distance is defined as the product of rate and time. And you know, of course, you can rewrite this equation in any form. So if they ask you to solve for R, that means you want to get r by itself, we could go ahead and divide both sides by t, and you would end up getting distance divided by time, which would give you the rate. And you know that's true because, you know, when we talk about calculating our car's average, we always talk in terms of miles per hour. So that's your distance and that's your time. So that gives you the rate for, you know, whatever example you're looking at. Sometimes, depending on if we're talking in terms of area, perimeter, or something like that, then of course you can fall back on the area perimeter for rectangles, squares, triangles, you know, that kind of thing, because sometimes they may ask you to maybe find the area. I've seen examples where they talk about, you know, those little triangular medians that you have on like, you know, intersections on the roads. They can talk in terms of, you know, what they're talking in terms of farmland or, you know, gardens and stuff like that. Painting a wall or, you know, laying the floor and just different types of examples. And, you know, all of these would need area and perimeter formula. So you can definitely fall back on known formulas, but then like I said, sometimes we may have to come up with our own equations. So the first thing we're actually starting out with is just making sure we are able to rearrange our formulas. So as you saw in example 1, we were talking about rearranging the distance, rate, and time formula. Here we have the equation of a line that they're asking us to get y by itself. This one here is the area of a trapezoid. So in this case, they're actually giving you values for all the variables except one, and they're asking you to find that missing value. So, you know, your trapezoid would look something like this, where these two would be our bases, and then that perpendicular distance is what would make up the height of our trapezoid over here. So just different examples of how we can rearrange our variables. So you will notice the first few examples in your 1.2 homework are going to be on that same type of examples where they're going to ask you to get one variable by itself. So how about, yeah, how about we look at this guy over here. So they are giving us S equals 5/4m plus 39, and they're asking you to get m by itself. So I'll give you guys a couple minutes, move everything else to the other side and get m by itself, and let me see out of these options A, B, C, and D, what you come up with. So again, just type your answer in, but don't send it in till I ask you to. You're just trying to get m by itself and moving everything else to the left-hand side. Okay, go ahead and send your answers in. We have got D, E4S minus 156 divided by 5. Okay, so it looks like you may have actually simplified your answer there, James. Ryan, same thing. Okay, so in this case, remember, you are just choosing between the options of A, B, C, and D, so we don't actually need to distribute the number. Okay, Trey, yeah, I figured something was definitely not working out the way it's supposed to. I just kind of hate seeing you having to leave so often because I'm sure you're missing a little bit part of the lecture, but that's okay. I'm okay with it. Okay. Alrighty, so you guys are basically choosing D as your answer option over here. Alrighty, so let's do a quick check over here. So you are given S equals 5/4m plus 39. So of course, our first step would be to move that 39 to the other side. So you would end up getting S minus 39. There we go. And then 5/4m on the other side. Now you can think of this as the fraction 5/4 being multiplied with m, or you can think of it individually as 5 times m and then being divided by 4. But the easiest way to get rid of it is just to invert that fraction and multiply it on both sides of your equation. So we would go ahead and invert that, 4/5, and you will see the 4 cancels out, the 5 cancels out, leaving us behind with just m. And then on the other side, you would have 4/5 s minus 39. So yeah, very good job on that option D, guys. So we'll do a quick check over here. And there you go. Alrighty. So like I said, you will just have a couple different examples where they will ask you to, rewrite the formula, rearrange it a little bit. I think you've got a couple more examples here. Same thing is happening here. Same thing's happening over here. They're asking you to write the formula in terms of S. So they are basically saying write S as a function on P and R. So just get S by itself on one side, everything else on the other side. Same thing is happening over here. Alrighty, how about this guy? So this one is actually asking you to solve and come up with the answer. So we are given the temperature in degrees Celsius, and they're asking us to convert this into obviously degrees Fahrenheit. So you can see they are giving us 10 degrees Celsius. You are going to plug that into your little formula over here. So 10 degrees Celsius is going to be how much in degrees Fahrenheit? So go ahead, work that out and let me see what you come up with. And they've actually given us a pretty nice number over here. So hopefully you should get a nice answer. Okay, if you're ready, go ahead and send your answers in. Okay. All right, 50 degrees Fahrenheit, 50, 50. Oliver, you got 22 degrees Fahrenheit. Yes, it looks like most of you are actually coming up with 50. Okay. So, Oliver, I'm kind of thinking maybe something went wrong in your calculation over there. So instead of C, we're going to replace that with 10 plus 32. And of course, you can see 5 will go into 10 2 times. So you don't have to worry about getting, decimal answers or anything like that. So of course, 9 times 2 would be 18. And 18 plus 32, yeah, looks like we should be coming up with 50. So how did you get 22 there? Oh, I see. Okay, not a problem. Alrighty, so let's do a quick check over here. So you can see 10 degrees Celsius is a pretty cool temperature because it's equivalent to 50 degrees Fahrenheit over here. So obviously a little bit on the cooler side. All right, very nice. Now, I believe after this is where they get into these application questions. Now this example, I do have that in your handout over here, so you should be able to follow this example to come up with that answer. But I just wanted to walk through the different steps of problem solving over here. So, you know, obviously you want to make sure you're reading the problem, understanding what is given to you, what they're asking you to find. So if it helps to read it multiple times, definitely do that. If it helps, you can draw a diagram so you can kind of visually see what they're talking about. So, you know, that's why I included these little illustrations over here, so it would make it easy to visualize what the problem is talking about. Now choose a variable, make sure you write down what it represents. So does the X represent the height? Does it represent, you know, a length or a width or a quantity? You know, whatever it would be, it's always better to write down what it represents. And you don't want to use too many new variables. If you've already chosen, let's say X as your variable, try to write other quantities in terms of X. So don't do like X and Y, because the more variables you bring in, the harder it's going to be to try and solve these equations. So we want to try and stay with just one variable in these examples especially. Now, once you have defined your variable, then you want to write an equation which would be for the example you're working on. So it should model that situation. If you can use any of the known formulas, like your distance, rate, and time, or area, perimeter kind of thing, then you can use that. Or if you need to come up with your own formula based on the equation, the problem, then you want to do that. Obviously, once we have the equation, we want to solve that equation. And then once you solve it, it's always a good idea to go back and check your answer in the original problem. Not the equation you came up with, but the original problem that was given to you. So that way we know it is satisfying the original situation which was given to us. And then, you know, make sure you're answering the question that the original problem asked you to answer. So just different steps that are involved. So I'm going to try and do a couple examples from here that, you know, may or may not be part of your handout. So this is a really nice example. They're actually, and you have this little illustration over here to help you out, but basically they are saying a carpenter used 43 feet of molding in 3 pieces to trim the garage. So as you can see, we have the longer piece on the top of the garage and the shorter pieces on each side of the garage. And so they are saying the long piece was 3 feet longer than twice the length of the shorter piece. And they basically want to know what is the length of each of those pieces over here. So you can already see in this case, if you look at the image over here, they're already using X for the shorter length over here. So which means this distance will be X. This distance here will also be X. So what do you think this distance is going to be for the longer side? And again, look at the description they have over here. They said the longer piece was 3 feet longer than twice the length of each shorter piece. So if the shorter piece is X, they are saying the longer piece is 3 foot longer than twice the length of the shorter piece. How would you write that expression? And you know, this is where that idea of using the same variable for writing other unknown quantities comes into play. Okay, Abdul Aziz, you've got 3 plus 2x. Let me make the screen a little bit smaller. Okay. So we know that the 2 shorter pieces are called X and X. So that's going to be the shorter piece, which is X. They are telling us it's twice the length of the shorter piece. So twice the length of the shorter piece would become 2 times X. And then they're telling us it is also 3 feet longer than twice that length. So that's going to be 3 feet longer than that. So you can use X as the length of the shorter piece. And then 2x plus 3 as the length of the longer piece. Okay. Now, how would you come up with your formula? Okay, Nathan, I just saw your answer. So you are looking at 2x plus parentheses 2x plus 3 equals 43. Yeah, and it is going to be 43, right? Because they're telling us the carpenter had a total of 43 feet of molding over here. So we know we have to add up all three sides to get a total of our 43 feet. So that's going to be x and x for the two shorter sides. Then it's going to be 2x plus 3 for the longer side. And then, of course, total would come out to be 43. So in this case, really all the information you needed was given to you in the formula itself. So again, guys, go ahead and solve for x and let me see what you come up with as your answer. Don't send it in till I ask you to, okay? Okay. Oliver, no problem. Hopefully here in a couple minutes, you should be able to go and get it out of the way. So, oh, okay, okay. So remember, you're sending me two measurements, one for the shorter piece and one for the longer piece. Because remember, X is going to give you the length of the shorter piece, and then you will need to calculate what that longer side of that garage is going to be. So I need two measurements. Okay, if you're ready, go ahead and send your answers in. Okay, so what's your second measurement, Abdulaziz? Okay, Oliver, you've got 10 and 13. 10 and 23 from Nathan, okay. So it looks like 10 seems to be the definite shorter length here. I'm getting 10 and 23 from Ryan, Shayna, okay. James. Okay, Abdulaziz 23. Yeah, so the first thing you would of course do is end up adding all of your x terms together, which would end up giving you 4x plus 3 equals 43. Then we would go ahead and subtract 3 on both sides. And you would have 40. And as you can see, when we divide both sides by 4, your shorter length does come out to be 10 feet. And then to calculate the longer one, we would just use that expression of 2x plus 3. So that would be 2 times 10 plus 3, which is of course 20 plus 3 as 23. So just be careful. The one thing I have noticed in this example that goes wrong is, you just end up switching the two answers in that boxes. So the first one is actually asking you for the longer piece. Oliver, you dropped the 2. I noticed that. Yeah, not a problem. Just be careful when you're working this example for homework. So the long piece would be 23, and then the shorter piece would be 10. And we'll do a quick check over here. And there we go. Okay, so just one of those examples you can kind of come across. This one here, where they're talking about fencing a square feedlot and then doing a cross fence on that, is actually similar to, oh, I clicked on the wrong one. There we go. Is actually similar to this example over here, number 6 from your handout. So you should be able to follow this example to try and come up with the answer for this guy over here. This problem over here is what we call as a work problem. You can see they're talking about Trent can deliver his newspapers in 60 minutes. Lois does that in 30 minutes. So if they were to work together, how long would it take them to work this, deliver the newspapers? So this is actually very similar to this Batman and Robin example. And I just picked up that example because I thought it was kind of a goofy example, but you still get the idea. And they will give you many different variations on this type of an example. So you can have, people raking a yard, mowing the lawn kind of thing. But sometimes they will actually use machines. So they will say, what happens if you use 2 water pumps to, empty a pool or something like that? Or if they're using 2 printing machines to do a job. Because, the idea here is it going to be more efficient to bring 2 people or 2 machines in? Is that going to help your job get done faster, or there's not going to be a much time difference? Because, sometimes you have to do these calculations in terms of, does it make more sense to hire extra people? Or is it going to be beneficial if we get extra machinery into our, production cycle or something like that? So that's kind of where this example, this idea comes into play. So again, look at example 7 to help you solve this one over here from the work problem. Now, the one example I actually wanted to look at was this one right over here. Number 12 is also given to you as the last problem over here. So you can follow example 8 for that, but I did want to talk about number 11 with you guys. So this one is actually talking about how to dilute a solution. So they are saying you have a 7% extract of Bainberry solution. You've got 9 liters of it, and you want to bring that concentration down from 7% to 4%. So they want to know how much water are you going to be adding to, create this less concentration. So how much water is actually going to tell you, what we are trying to find. So you can say X is going to be the quantity of water that is going to be added to this solution. Now, the way this example is going to work out is you actually have to take the concentration of the solution with the quantity. So the first part they're telling us we have 7% of this Bainberry extract solution, and we have 9 liters of it. Now we are trying to bring this concentration down from 7% to 4%. Now think about this. You're starting out with 9 liters, but what's going to happen when you add water to it? Your quantity is going to go up, right? Your quantity is going to increase. So since we are decreasing that concentration down from 7% to 4%, by adding water, you actually have to take into consideration how much water you are adding to make this a lower concentration. So it's pretty straightforward the way you set up your equation, but yeah, just be careful. By adding water, you are also increasing the quantity of this solution. Now, guys, whenever you are working with percents, always remember to convert your percents into decimals, okay? That's always by default. So before you start solving this equation, you want to go ahead and rewrite those 7% as 0.07 multiplied with 9, and that 4% as 0.04 multiplied with 9 plus x. So let me see what you come up with for the x value here, which will be the liters of the water that is being added. Okay, so if you have your answer, go ahead and share that, guys. 6.75 liters. Oliver, you got 0.27. It looks like 6.75. is what you guys are coming up with. Okay, so as you can see, I was trying to simplify this problem over here. So if you go ahead and subtract that 0.36 on both sides, we will end up getting 0.27 and then 0.04x on the other side. When you divide 0.04 on both sides, what do we end up getting? Okay, that will end up giving us x equals 6.75, and then remember this is going to be in terms of liters. Now let me look at what the instructions are over here. It says integer or simplified fraction, so actually they're not going to accept our 6.75 answer. So what you can actually do in this case is you will notice you have 0.27 divided by 0.04. Now these are both 2 decimals, so you can just move that decimal 2 places to the right and you will end up getting 27/4. Or if your calculators will convert decimals to fractions, you can definitely use your calculator. Yeah, Oliver, so 27/4 liters is what we are actually going to be typing in for our answer. So let's do a quick check over here. And you can see that's what they wanted us to do. So just be careful. Like I was telling you before, underneath each answer box, they will tell you what kind of answers they want. So they want an integer or a simplified fraction in this case. So just a quick look at sections 1.1 and 1.2. If you did not get a chance to watch the video lectures for these 2 sections, just make sure you do, so you know what those examples from your handout end up looking like. And then for our next class, which for you guys will be now on Monday afternoon, we're going to be looking at 1.3, 1.4, and 1.5. 1.4 technically is a review section. So you will notice in my math lab, there is no homework for 1.4, and you will not even be tested on 1.4. So we're going to be just doing a quick look at 1.4 as a review section, because those concepts actually are used in other sections. So yeah, we'll be doing 1.3, 1.4, and 1.5 for our class on Monday. And again, guys, just please make sure you're working on your homework. You've got 9 sections of homework, so don't fall behind. I have office hours tomorrow from 12 to 1 if you need any extra help, or you can just send me an email. Okay? Any questions before we dismiss class for today? You guys are good? All right, everybody, have a wonderful weekend. Be safe, and I will see you on Monday.
Have a good weekend. Thank you.
Bye. You can move your car now.
Great, thank you.
Bye. Thank you. Take care. Bye, everyone.